Alright, today I will be going through how to determine the line of intersection of two planes. The problem I will be using can be found in the final exam review sheet. It's problem 42. Here we have two planes, x minus 2y minus z equals 4, and negative x plus 3y plus 4z equals 1. We'd like to find the equation of the line that defines where these two planes intersect with one another. To start, we need to find the common point between the two planes. In order to do this, we have to set up a system of equations in order to narrow down the number of variables we have to deal with. Luckily, this set is already able to cancel out a variable, the x. Otherwise, we'd have to multiply one of the equations in order to get one to cancel. So now we've found that y is equal to negative 3z plus 5. In order to solve this, we need a value for z. We can just assign one to it. Let's say that z is equal to 2. Now we can substitute this into our equation and find y to be negative 1. Now we can plug those values into one of our initial equations and solve for x. We can simplify this and end up with x being equal to 4. We've now found the common point between the two planes at 4, negative 1, 2. Now this point we just found is just one of an infinite number of points that we could have found being common between the two planes. At this point, it's always a good idea to double check and make sure that this point works with the other equation. If we substitute the point that we just found into the equation that we didn't use earlier, we can find that it does indeed work out. Now that we have a point, we need to find the direction vector in order to fully realize the line of intersection. To do this, we first need to find the normal vectors of the two planes. Normal vectors are quite easy to define when we have the equation of the plane. I've highlighted where the vector values are coming from to make this easy to see. The direction vector we are looking for can be found by taking the cross product of the two planes' normal vectors. And now we have our direction vector, and it's equal to negative 5i minus 3j plus k. Now that we've found both our common point and our direction vector, it's just a simple step of combining the two to find our line of intersection. So here's our line of intersection and the parametric equations that make it up. X equals 4 minus 5t, y equals negative 1 minus 3t, and z equals 2 plus t. So it's been a couple of months since we had this unit, and I hope this was a good refresher for everybody.